Hello ladies and gentlemen, and welcome to this third part of Linux, in which I said last time that I was going to go through USB devices, and I have here a USB memory stick, and I also have a USB hard drive, and we're going to be going through these. In fact, I'm going to attach them to the machine now. Right, they are both attached. So let's see what happens. Not 100% sure what we've got. Oh, there we go. 240 gig volume. So you can see they've come up. And I'm going to do this by starting off and by giving you the information that you need, and then slowly go down the rabbit hole of various things. So once you've gone as far as you want to, you can bail. And there's no shame in that. So there are two ways. One is a complex tool and one is a simple tool. And one of these you should find under accessories, I think, is a USB image writer and a USB stick formatter. The image writer is when you have the easiest way is if I wanted to transfer a CD to you, I would make an image of the CD which would go into a file. I would transfer the file electronically to you, and then you would write that image back to a CD. And that is traditionally how a lot of install media was done by CD. And that's pretty much the only way that you've got to transmit the install media to somebody else for them to then burn to a CD at their end. These days, that's sort of changed to USB sticks instead of using CDs. So, yeah, you get an ISO image, and you can use the USB image writer to write that image to a USB stick. But that's not what we're going to be focusing on today. We're going to be focusing on the USB stick formatter. Now, this should only present you with any storage media which is connected via USB. So you can see we've got the 240 gig and the 8 gig drives that I've attached via USB, and it's not showing you the internal hard drive. That makes it a bit safer for you. And it usually tries to protect you by giving you only 4 different file system options to choose from: FAT32, Exfat, NTFS and ext4. 3 of those you've probably heard of before: FAT32, Exfat and NTFS. You can specify a volume label when you want to format it, and we're going to format the 8 gig USB stick. We're going to say 8 gig stick. That's what we're going to call it. And we're going to format this as FAT32. Now this, there you go. You probably want to screenshot this, and I'm just making sure that my head's out of the way. FAT32 is compatible everywhere, but it can't handle files larger than 4 gig. Exfat is compatible almost everywhere, can handle files larger than 4 gig, but it's not as compatible as FAT32. NTFS is compatible with Windows, not compatible with Mac and most hardware devices. Occasionally compatibility problems with Linux, because NTFS is proprietary and was reverse engineered. We'll go into all this. And ext4, which is modern, stable, fast, journalized, which we'll go into again, supports Linux file permissions, which are not necessarily what you want. We'll talk about that. And it's not compatible with Windows, Mac and most hardware devices. So, what is my personal recommendation? If you've got a USB memory stick, which is 32 gig or less, I would recommend using FAT32. If you've got a USB memory stick which is 64 gig or more, and that includes SD cards for cameras and things like that, I would recommend Exfat. If you're using a hard disk like the 250 gig one we've got attached via USB, I'd recommend NTFS. So this is an 8 gig stick. I'm going to format it as FAT32. So it's asking for confirmation before to make sure that we actually want to do this. So we're doing that, and it's formatting it for us. Successful. Ta-da! You'll notice that it vanished from the left-hand side, and it should hopefully come back. And we're going to format the 240 gig as NTFS. 240 gig SSD, and that's gone, and that's formatted successfully. We might actually have to reinsert them. There they are. They need to be remounted, and when we click on them they remount, and you'll see them come in on the left hand side. So now they're blank, there's nothing on them. So you can do the usual thing to transfer files to them. You can either select on something and use copy, and then go to the destination and click paste, or you can drag and drop. If you want to make a copy of a home directory of everything you've got, for example, you can see here that we're in the home directory. We're just going to go up a level to home. If you remember the structure, you've got the root, which has got all the various media, MNT, and home folders in it. And then in the home folder, you've got one folder for every user. So if I right click on this folder and go to properties, it'll tell me how much space it all takes up, 7.7 gig. Oh, I could actually fit this on the 8 gig stick. So I'm going to drag that into here, and that is now going to go away and copy all those files over. So that's the most reasonable basics that you need to just format a stick and to put it in. You note that we have the eject button here, and also if we right click on something, you have the eject there. Why would you want to use the eject? You'd want to use the eject because of a cache, as it's known. Just imagine yourself with a bucket and a water tap and a big pool, a big swimming pool, and you've got to fill the bucket and then with water, then empty it into the pool, go back, fill the bucket again, and keep doing it until you're transferring all the data. There will come a time where you'll come to the last of the water out the tap, but it won't be enough to fill the bucket. So you're sort of stood halfway between, do I wait for more water to come out the tap, or do I go to the pool and throw in the remaining water that I got in the bucket? And that's pretty much the conundrum that the operating system is in, be it Windows, Linux, whatever. You've got that cache. You've got that little bit of information stuck in that bucket, and it's thinking, do I actually write it to the device or wait for more information to come so I've got a full bucket to pass through? And basically that's what's happening. So if you transfer a load of equipment, a load of data quickly, and then you just take the drive out, there's going to be information waiting in that cache that hasn't yet been transferred to the drive, and you're taking it out before it's complete. By selecting eject, we tell it, okay, here's your decision, go and empty your bucket in the pool, and then we can take the thing out. Now there is a timeout by which, you know, you'll only wait for so long before you think, I look like a right wally here, and you'll go and empty the water anyway, and then get on with something else. And that is what the computer does do. There is a timeout. But by using the eject, you're making sure that anything that's in that cache has got written, and you've got everything. Otherwise, if you rip it out before you hit the eject, there could be information still in the cache, and you'll be taking out and the drive out, and it hasn't all been written. So that's why you use the eject. Now, as you can see, we've pretty much got a copy of everything here. Everything that's in there is in there. We've got all 7.7 gig in there. And that's a relatively easy way to back up all your files, all your documents, all your music, all your pictures. Just copy it out to a USB drive that's big enough. Yeah. So why FAT32 and Exfat and NTFS? Well, in the beginning, for example, for a start, Microsoft Windows only supports Microsoft Windows file systems like FAT32, Exfat, NTFS. It doesn't support other file systems, like I think the Mac file system also isn't supported. ext4 isn't supported. And that, it sort of harks back to Steve Ballmer's days, when Steve Ballmer was in charge of Microsoft, and he viewed Linux and open source as an enemy to be defeated. So, traditionally, when you had something like a digital camera or any other digital device, and it was the same pretty much with, anything, pretty much, which had data on it, including dictaphones, anything of that nature, they would store the data on the device in a proprietary format. You would have to load software onto your machine, hook it up via USB, and the software would take the data off the device and put it on your local machine as a file. There were a number of reasons for this, but one of them was FAT, the file allocation table. And if we look up the wiki on FAT, wiki FAT file allocation table. What if we put the word Microsoft file allocation table? There you go. It was originally developed in 1977 for various bits and pieces. And there's original 8-bit FAT. We'll go through this. FAT12, FAT16, logical sectored FAT, final FAT16, FAT32, extended attributes, long file names, all the rest of it, FAT plus, FATX, and Exfat, and patents. Microsoft applied for and was granted a series of patents for key parts of the FAT file system in the mid-90s. All 4 pertain to long file name extensions to FAT, first seen in Windows 95. On December the 3rd, 2003, Microsoft announced that it would be offering licenses for the use of its FAT specification and associated intellectual property at the cost of 1/4 cent royalty per unit sold. So what that meant was that devices like this could now have a memory card in there, and they could use the FAT filing system, which enabled you to then just take the memory card out, put it in your Windows machine, and Windows would see it. Bingo. But they had to pay 25 cents royalty for every unit that was sold. Whether that's still the case, I'm not sure. But by restricting Windows to the Microsoft file systems, they circumvented anyone using any other filing system. For example, if it was possible for the camera to use ext4, then they could use that license free. You could take your card out with ext4, plug it into Windows, and Windows would read it. Microsoft didn't like that. It denied them the royalties by pretty much having so many workstations all over the place. People were pretty much forced to use their file systems if they wanted things to work seamlessly, and then had to pay them the royalty. So that's one thing. The other thing is permissions. And as you noted, in the USB formatting, USB stick formatter, if I hover over this, it supports Linux file permissions. Now that's not necessarily something you want to do. Most people want to store things on USB or memory sticks or portable hard drives in order to transfer them somewhere else or to load them on another system. On top of the fact, even if you are sharing between two Linux systems, you still want to use FAT32, Exfat or NTFS. To cut a very long story very short, or as short as I can, when Windows was created, or rather MS-DOS, or however far you want to go back, it was created for a personal computer, which means that one person would be sat at the computer and only one person would be using it at any one time. So having a permissions structure within the file storage was pretty much nonsensical. It didn't make, it was an overhead that wasn't needed. And that's the case with FAT32 Exfat. I don't think that there's any permissions on any of them. NTFS does have permissions, but only under certain circumstances. The default is allow everything anywhere until certain permissions are put onto something. So by default, although NTFS does have permissions, everything is allowed. So if you transfer anything to NTFS, it's typically got allowed, unless somebody has deliberately taken some action which messes with that. Linux sort of supports NTFS permissions, but that's another story that we're not going to get into here. Linux, on the other hand, comes from the stable of Unix. And even a Linux machine can support a number of people connecting to it at any one time. And Unix, coming from the mini computer, and I mean mini computer as in a computer which was mini compared to a mainframe. A mainframe you'd have to create a dedicated large room for. A mini computer would fit inside your average office room but still be pretty chunky, and it was still designed for many people to use it simultaneously. So in that kind of environment, permissions was core to the operating system. Permissions were core to how files were stored. So permissions were built into the whole thing, and indeed permissions are built into Linux. The only reason why you can get around a chunk of this stuff is because it's still only you that's using the machine. You're still effectively logging on, it still knows who you are, and you are still having to feed a password to elevate your permissions when you want to do something serious. And that's why I say don't use ext4. Not only can Windows not see it, but if you write files to a USB stick formatted to ext4 on your machine and you transfer it to another Linux machine, there's no guarantee that machine is not going to say, oh, I don't have permissions to read these files. And then you're in a bit of a world of pain. You've got to learn permissions and how to handle them. So that's why I'm stay away from ext4 for media. Now, there is one other thing that ext4 says, and that it's journalized. FAT32 and Exfat are not journaled, but NTFS, I believe, is journaled. What does journaling mean? Well, basically, it keeps a record of what it's doing with a file. So that if it is, if something untoward happens in the middle of operating on that file, when it comes back up, it can look through the journal and see where it was, and then take action according to that. Either declare the file as it was only half written, forget about it, or it can make a decision because it's got a journaled record of what it was doing at the time it was interrupted. FAT32 and Exfat are not journaled, so they don't have that ability. If something goes wrong, then when you bring it up, you're possibly dealing with corrupt files you don't know. And there's no opportunity for the operating system to actually put things right. So that's the important thing about this. The other important thing is about history. You'll note that, and we're just going to look at FAT here. There you go. It was first developed in 1977 for use on floppy disks. Now, storage is basically a notebook. You can consider it to be a notebook. And information can go in there all over the place. And information is written to and removed from various pages as the device is used. With an actual notebook, you stand a bit of a chance of flipping through the pages, reading all of them to find the information you need. That's not very efficient, but it is possible. And on the early floppy disks, you could only store a matter of K, about 400K on some of them. So the only way, really, to find information was to have an index. If you had to find the index, looked up the index to where the information was, and then flipped to the page. That's pretty much how it works. And the index is so important that on some hard disks, it's actually stored in multiple places. There's multiple copies of the index, because if the index goes, you've had it, pretty much. And some of the confirmation is that multiple copies of the index are compared against each other, and if there's discrepancies, the majority copies that agree with each other is taken as the definitive. Yep, that's where this file is. This is how long that file is. This is its name, yada yada. But right in the beginning, because there was so little room on a floppy disk, the index file was limited. A certain amount of that notebook, only 1 or 2 pages, was given over to the index. The rest of it was for storing your notes. That brought about limitations. Once you'd used those 2 pages, that was it. You could erase an entry and add a new one in, but there was a limit to how much index information you could keep on those couple of pages. That limited the number of files that were on there, and other things, and has other limits. So you have all this stuff, and it starts with the original 8-bit FAT, which had quite some severe limits. Then it actually changed to FAT12 between April and August 1980, while borrowing the FAT concept for SCP's own 8086 operating system, QDOS. Tim Patterson extended the table element to 12 bits, reduced the number of FATs to 2, redefined the semantics of some of the reserved cluster values, and modified the disk layout so that the root directory was now located between the FAT and the data area. In other words, all of this is doing is altering how the index is organized and where it is stored in the notebook and that kind of things, and changing how it operates. And that's what happens with the various versions. So that's why somebody says, well, I'm storing it, formatting to FAT. Yeah, but which one? In a lot of cases, when a lot of stuff says FAT, just FAT, without saying FAT32, it usually means FAT16. And it actually means one of the final FAT16 version. Introduced what today is simply known as the FAT16 format, with the expansion of the 16-bit sector count to 32 bits, and various odds and sods. The key things that you'll come across are FAT32 now. You'll still come across FAT, which is probably FAT16, but these days you'll probably come through FAT32, Exfat, which is overcomes some of the file size and storage limitations of FAT32. It's the next one in the FAT series, effectively-ish. And yeah, you shouldn't have to worry about a lot of this stuff, because Windows and other devices will take care of it for you. If I was to put a micro SD card in that camera, I could tell it in the menu to format the card, and it would format it for me to whatever the camera deals most appropriate. And if I was to plug it into a Windows machine, it would probably take it quite happily, or at least into a later Windows machine. I think you'd have to go to, I'm not sure whether Exfat was actually supported in XP or Windows 7. Exfat. Oh, it is. It was actually introduced with the Windows Embedded CE in 2006. Wow, that early. And was supported in XP with Service Pack 3. Loosely based on the FAT architecture, but incomplete, proprietary and protected by patents. Yeah. So it's intended for use on flash drives such as SDXC, which is the larger form versions of SD cards and memory sticks, where otherwise you would have used FAT32. So that's where Exfat is aimed at. And yeah, pretty much a number of the patents expired in 2011. Non-Microsoft patents affecting FAT include specific to the OS2, if you remember that operating system, but I'm not sure which patents are still active. And you've got whole loads of all the patents are just bonkers. If you in 2013, patent EP06 blah blah blah, common namespace for long and short file names, expired since 2014, was invalidated in Germany. After the appeal was withdrawn, the judgment became final on the 28th of October 2015. So exactly what is and isn't protected still and enforced by Microsoft, I'm not 100% sure. And which is why some reverse engineering has had to be done, and yeah, and why some things are a bit odd. There were attempts, I think most appropriately with Windows XP, to load drivers so that other file systems could be used with Windows. I'm not sure where they all went, but pretty much with tighter driver control by Microsoft, a lot of them, you had to get stuff signed and all that sort of jazz. It did become more difficult, and a lot of people just basically abandoned the attempt to get to write software to enable other file allocation file systems to be readable on Windows. It was a bit bonkers. Some of the later versions of file systems allowed not only allowed more files because you had more space to play with, you could have a larger index, but it was what also allowed longer file names as opposed to the, what was it, 7.3 or 8.3? I think it was 7.3. You could then have long file names. You could then have subdirectories or folders, like we've got now. And all this stuff was a bit, there was a lot of argy-bargy. In February 2009, Microsoft filed a patent infringement lawsuit against TomTom, alleging that the device maker's products infringe on patents relating to VFAT long file names. Oh yeah, VFAT. As some TomTom products are based on Linux, this marked the first time that Microsoft tried to enforce its patents against the Linux platform. The lawsuit was settled out of court the following month, with an agreement that Microsoft be given access to 4 of TomTom's patents, that TomTom will drop support for the VFAT long file name from its products, and that in return Microsoft not seek legal action against TomTom for the 5-year duration of the settlement agreement. So all this stuff gets very messy. Very messy indeed. But, yeah. So let's take a look at another one of the tools, gparted. gparted, G stands for GNOME, which is one of the desktop environments. The one that we're using on Mint is known as Cinnamon. So we're using Linux Mint Cinnamon, but we could use Linux Mint Mate. And this is a tool from the GNOME desktop that we're using, and Parted is a partition editor. So you'll probably be used to this. If you've used Partition Magic, or something that we used to use on Windows, something we used to call Partition Tragic in the early days, because sometimes it didn't work and it took your entire drive out. This is a partition editor, and this time you can see not only the 2 USB drives, but you can also see the drive which is local in the machine on the SATA channel. So yeah, and you can change things. You can see that the Linux disk contains an EFI boot partition, because this is it boots off EFI, and there's then one major partition of 118 gig. We've used 25 gig, 90, and there's the ext4 partition, which is the default partition for Linux these days, most Linux these days. So you can pretty much see how that is made up and how much is in use. Now, partition editors are used to change things. That actually needs a refresh. Refresh devices. I might actually have to take that out and put it back on again, which we will do now. If we refresh the devices, that will notice that it's gone. And if I put it back in again, give it a few moments, and then refresh the devices, it should see it back there, and it's still labelled as Linux Mint, but it's got the partition that we put on it. I'm sure I labelled it. Anyway, here we got this. If we ask to format it to, you can see a considerable range of file systems to use. Not only do you have ext2 and ext3, as well as ext4, which are older versions of ext, you can also see NTFS in here. Exfat is greyed out, but FAT32 is there, as is FAT16. You've got the Resize FS, which version of that I'm not sure. And, Minix file systems, BTRFS. There's a load of, you've got a Hewlett-Packard file system there. Linux Swap is a specialist file system. if you know about Windows swap files, then you'll know that what happens is that Windows keeps a large file and uses it as swap space, but it is on the main partition. You can change it, but one thing that happens with a swap file sometimes is that it will end up getting fragmented, and it is basically a file. So what Linux does is you have a specific swap partition, so it's not accessed like a file, so it can be used more efficiently, and typically you put it at the start of the drive. Typically, in order for that the drive heads can access it more easily, and it's a swap partition of its own, so it's not used for anything else. With SSD drives, it's typically not needed, and if you've got enough memory, there's no. I think I told this to just format everything and take over, and it didn't put a swap partition on there. Whether it had a look at the amount of memory in the system and determined don't actually need one, I don't know. But typically a swap file is used when you don't have that much RAM in a machine, and it's like memory. If you can store eight ideas at once, if you've only got the space to store 4 ideas at once, then it's got to offload the other 4 ideas to somewhere else, and it does that and stores them on swap. That's why it uses swap. That's why an operating system uses swap. If it needs so much memory, but it hasn't got enough physical memory to do its job, it will dump stuff off temporarily to the swap partition. And that's one reason why I typically go for a lot of RAM in machines. If you've got enough RAM to do what you need to do, then there's no need to use swap. So there's no need to put extra strain on the hard drive. But in the early days of IT, when RAM was quite expensive, swap was pretty much used out there. But in Linux, rather than swap being a file on the main file system, it has its own partition. So I could put a swap partition in here. The other thing that I will show you, and I will do that here, is that you can make resize partitions. This is what a partition editor does. So you can, I can resize this. In fact, I don't think there is anything on there, is there? So let's just create a new partition table on here, and we'll just use an MS-DOS partition table for compatibility. So there it is, unallocated. I can give a new partition, or I can put one on there, file system ext4, we'll just make it FAT32, we'll add that. I'll put a new partition in, FAT32, and then you can resize them. I'll just apply that. So here we are with 2 partitions on this drive, and it's doing it. Should probably have done it on the other one, all successfully completed. Now, why would you use partitions? I normally use partitions to separate the operating system from the files. One of the things with Windows is that it puts all your personal files on your C drive under a folder typically called users. It depends on the version. But if the operating system goes gaga and you need to reinstall the operating system on Windows, you've got to take everything off and then take all your personal data off before you can then format the drive. With this, because you have mount points, and I actually haven't put mount points on here, don't worry. I could have the operating system in one chunk and all my /home could be in here. So if I needed to reformat the operating system, I could just say, okay, total trash that partition and put it and do it all again. And I wouldn't have had to have copied the data off because it is in a separate partition, which is safe. And you can occasionally, what you find typically is that one partition gets a bit full, so you've got to shift things around. So you can actually resize and move them. So I can create some free space in front of here, moving our partition make contact, yeah, and then I can resize this one to take up the space, or I could actually move it to a different point as well. So yeah, so I can move it. There's a bit of unallocated there, 1 meg, and that will shift everything. So it'll move all the data around and edit the partitions, which is what it's doing. It's a partition editor. It's editing the partitions. And this is something which is a useful tool, especially when it comes to sorting out some machines, because you can load Linux itself onto a USB stick as what's called a live image. So rather than booting from the internal hard drive of the computer, you can boot it from the USB stick. And with tools like this available to you, you're able to work on the hard drive that's in the machine and move things around and copy things on and off as you need to in order to get some repair work done. Yeah, this is going to take a while. So we are just going to cancel that. I'm going to force cancel because it's altering stuff. Yeah, cancel the operation because effectively we're mucking around with everything there. And it's going to take a short while to actually cancel that, because moving stuff around on partitions is pretty serious stuff. So you're not meant to cancel it. You're meant to let it do its thing, but we're not going to leave it do its thing for 7.5 minutes. So we've force cancelled it, and it's trying to sort itself out as best it can, so that at least it's ending up in a reasonable state. Yeah, cancel operation. Close. Right, that is now toasted. It doesn't know what's going on, so we're just going to create a new partition table, and new partition FAT32, and write it, because I mucked around basically. And there we go. And that's now happy again. So Resize FS, I think, used to be the one of the file systems of choice for Linux until I think the inventor ended up with file system. He ended up in jail, I think. Resize FS. It went through a number of versions. For version 4, see Resize 4. This went, led by Hans Resize. And Hans Resize, in April 2008, he was convicted of first-degree murder of his wife, Nina Resize, who disappeared in September 2006. He subsequently pleaded guilty to a reduced charge of second-degree murder, and which included disclosing the location of Nina Resize's body, which was in a shallow grave near the couple's home. And who knows how long he's going to be in jail for. Criminal penalty 15 years to life. Parole in 2020 was refused. Next hearings in 2023. And so ext is now used. Resize FS was the default file system in Novell's SUSE Linux Enterprise until Novell decided to move to ext3 for future releases in 2006, which is when when all this came about with Hans and his wife disappearing. Yeah. Yeah, there's an awful lot of history here. But the basics is that file systems, they have been around since the year dot, because they are the necessary way of putting information onto storage media and knowing where it is and being able to access it. But file systems themselves have changed over the years according to need, features, all that sort of good stuff. And yeah, sometimes what looks like a simple tag, FAT16, well, FAT, turns out to have a lot more behind it, and many different versions, as you've seen. 8-bit FAT, FAT 12, 16, 32, and development, extended attributes, long file names were added, forks, FAT plus, turbo FAT, FATX and Exfat were derivatives of FAT, the file allocation table, and yeah. So pretty much, if you're storing media if you're storing stuff on USB media, the typical need is to have it accessible on other computers, which means you need to make it as accessible as possible, which means you need to be aware of the different options and the potential issues with permissions that you will need to deal with if you deal with a permissions-based system. And we'll ask for a wiki on journaling file system. And here we go. A journaling file system is a file system that keeps track of changes not yet committed to the file system's main part by recording the goal of such changes in a data structure known as a journal, which is usually a circular log. In the event of a system crash or power failure, such file systems can be brought back online more quickly with a lower likelihood of becoming corrupted. Depending on the actual implementation, a journaling file system may only keep track of stored metadata, resulting in improved performance at the expense of increased possibility for data encryption. Alternatively, a journaling file system may track both stored data and related metadata, while some implementations allow selectable behavior in this regard. The first one introduced in 1990, they introduced JFS, which is one of the first Unix commercial file systems that implemented journaling. So this goes back a fair way. You know, it's quite a way. There you go. This was subsequently implemented in Microsoft Windows NT's NTFS file system in 1993 and in Linux ext3 file system in 2001. So there you go. Rationale: updating reflects systems. For example, deleting a file on a Unix file system involves 3 steps: removing its directory entry, releasing the inode to the full pool of free inodes, and returning all disk blocks to the pool of free disk blocks. If a crash occurs after step 1 and before step 2, there'll be an orphaned inode and hence a storage leak. If a crash occurs between steps 2 and 3, then the blocks previously used by the file cannot be used for new files, effectively decreasing the storage capacity of the file system. So that's why journaling works. It's multiple steps. You don't just delete an entry and that's it, or you do one FAT, I think, and a few others that aren't journaled, but they literally have to, the blocks that were used have to be noted as free again and can be used. Otherwise the system knows those pages are used, but I'm not sure what for. They're not on the index, and you've got problems. So using a journaled file system helps these things, but again, it's not straightforward. As you can see, there are different levels of journaling, different ways of implementing it, And yeah, it's a bit awkward. Yeah. One of the other things that I'm not sure if I showed you before is one of the yeah, I'm pretty sure I have actually shown you before, is actually under administration, I think. Disk Usage Analyzer. Yes, I must have shown you this before. Michelle test root home folder, and it will show you how much is in each of these particular directories, so you can see how much is stored where. There's a few things already in here, because in the next one we're actually going to go through images and the imaging programs that are available to you, because pretty much one of the other common things that people do is they handle their pictures. And because Linux does support FAT and NTFS, you can have your camera take your SD card out, chuck it in here, and it'll work, and you can see things and copy things and various things like that. So that's one of the things. That's what we're going to go through next. We're going to have a look at pictures and the programs that are there to help you organize and edit your pictures to varying degrees, to be honest, because some of the tools are nice and quick and simple depending on what you want to do. Others are pretty heavy. Yeah, we're talking full-blown alternatives to Photoshop, and some of them actually work on Windows as well, so you haven't got to be using Linux to use them. So if you want to, if you need the power of Photoshop but you can't pay the money for Photoshop, GIMP is a good one, but we'll come on to that in the next video. So there you go, pretty much. That's how a lot of this stuff is put together. It's relatively straightforward. There's a lot of history and variants that are behind the scenes that hopefully, thankfully, you haven't got to know a lot about. You just have to know the limitations of each of the file systems that you're choosing. ext4 being Unix/Linux could give you permissions issues if you use ext4 on removable media to transfer files to another Linux machine. If you try and transfer it to an Apple or Windows machine, then it just won't see it at all. So it's typically best to stick to one of the three main Microsoft ones, which will give you the most chance of doing things, of getting another machine to read things back again. As I said, FAT32 is what I would personally go for a memory stick which is 32 gig or less, with the caveat that the largest single file size is 4 gig. So if you're using it to transfer a lot of files that you've zipped into one big zip file, and that zip file is more than 4 gig, you will have problems. It'll just say, I can't do this. Then you will have to either go and format it to Exfat or NTFS. And I would probably err on NTFS over Exfat, simply because it is it's been around a bit longer, I think, and it's more likely to be supported than Exfat. I still don't know what's going on with the with the patents of Exfat and NTFS, because some of those patents don't necessarily apply to the file systems themselves. They apply to various features, such as long file names. And some of those have expired, and it's all, you know, there's a whole loads of agreements and court cases going on behind the scenes that we never hear of unless you happen to be in the industry. So there you go. You've got a nice simple tool under accessories to format USB sticks. Why that didn't take the label, I don't know. Yeah. So better USB disk to version 2. Yeah, why I didn't do the label, I'm not sure. I'll have to look into that one. But anyway, you can always use gparted, which is under administration. Gparted under administration. You can always select it. Wait until it's woken up. Is it mounted? No, it's not mounted. You can label it there. And edit the label there. So that's that labeled to 8 gig USB, and I should be able to mount it. New UUID. That's where it probably got knocked up, because I'm messing around with things really in ways that you wouldn't normally mess around with stuff, if you know what I mean. So if we mount that again, that should hopefully come in. Oh, it took for 240 gig SSD. It knew that was renamed, but why didn't it know that one? And that one's now come at 8 gig USB. But note this in capitals. Right. Yeah, even though I put small letters in, labeling on FAT32 is not straightforward. That's why it took the label. The label took on the NTFS, no problem, but it didn't take on the one that I put to FAT32. I'm telling you. So yeah, that's about it. If you do an operation, it's just as easy to just remove it and put it back in again. And when I actually click on it here, then it will appear over there, because clicking on it here will have the action of mounting it. You can see that there's no eject symbol by it. It knows the device is in the machine, but I haven't actively mounted it. So when I click on this, it will mount it. You know, the eject symbol comes up, and you'll now see that it's over there, and we can view it and do whatever we want with it. So yeah, so we can eject those, and they will vanish from the left-hand side. Why has 8 gig SSD vanished? Why has the flash drive vanished? Let's just take it out and put it back in again. Yeah. You're not only dealing with the operating system, you're also dealing with the electronics and programming and the firmware that is on the device that you're talking with. So even though they're talking via USB, there's different firmware on the drives, and they behave differently. What can you say? It is one of those problems. It's why when we work on Xboxes, for example, and we want to put certain bootable media on certain things, only certain types of USB will work because of certain electronics and firmware that are on those sticks. USB storage is not straightforward, and that's another reason why some brands have better reputation than others. But hey ho. So we'll eject that, and it's gone. 250 gig SSD, eject that, and it's still there. USB media, real pain in the neck. And we treat all this as if it was just... One thing that I hope I've given you is a bit of a window into how all this stuff that we think is straightforward isn't actually straightforward. Why did that go up there? Oh, it's snap mode. Hold control to enter snap mode. So if I went up to that, it would snap up there and bring it back down, and it doesn't. And you can use hold control to enter snap mode. Use the arrow and mouse keyboards to switch workspaces while dragging. So if you know workspaces, which I've only put 2 workspaces on here, you can actually shift the workspace while you're dragging them. Cool. One of the other interesting things about some of this stuff is if you right click, not only can you move to another workspace, not only can you move something to another workspace, but if you are, you can also make visible on all workspaces. So you can make one thing visible on multiple workspaces if you're switching between other stuff. But also if you're using multiple monitors, you can actually use this and you can say move to the other monitor. So whatever monitor it's on, it'll move, which I find is very handy. It's another thing that they haven't done on Windows yet, but they'll catch up. And so that's pretty cool. A lot of us take USB file systems for granted, when actually there's a lot of history behind them, a lot of development behind them. They continue to go on in different versions and continue to be worked on, and new features are coming in to the file systems even as we're using them. It's we take a lot for granted, really, and we just treat a lot of stuff as automatic, when actually there's a lot of history behind it, a lot of complexity, and sometimes stuff just doesn't work and we don't know why, because there's a lot of complexity going on, pretty much. So I hope that's given you a bit more insight into the different file systems, when to use them, what their key limitations are, and fortunately the simple formatting tool shields you from a lot of stuff. It prevents you from accidentally formatting a drive that's on SATA, which will typically be your operating system drive, and it limits the choices of which file system to format it to. So it's saving you some grief. It's saving you some grief there. But yeah, that's about it. See you on the next video, when we will be looking at pictures and the various tools to handle those. So I'll see you then. Until then, ciao for now.